In this video, we will walk through a few examples of the results produced by the Lakehouse Optimizer's Unity Catalog Migration Assessment. If you need help setting up and running the assessment process itself, please see the previous video in this series. The assessment process is made up of a series of steps, and to view those, you can click the Show Previous Steps link under the Assessment Run Steps section. The Lakehouse Optimizer's Unity Catalog assessment is not omniscient. It can only see what Databricks allows it to see, and in some cases, Databricks will return with an error when it tries to read something. If you are lucky, the run bar will be green and say Assessment Completed, meaning the assessment process could see everything it needed to and your results are as accurate as possible. However, more often than not, it will say Assessment Completed with warnings, and most likely these warnings will be part of the Retrieve Table Extended Information step. This step can run into data inconsistencies, usually either data orphans or unexpected file types that are not Delta format but still hold actual data, like a CSV or Parquet file. In these cases, the Databricks API returns an error, and the Lakehouse Optimizer can't accurately assess if there's something to migrate or not. So the process logs this as an error it received when it requested the information from Databricks. You will want to investigate these because they essentially indicate information missing from the assessment results. To do so, we can scroll down to the bottom of the assessment page and click Assessment Logs. Most of these errors will either be Table does not exist, is not a Delta table, or possibly access is denied to an external location. In this example, if we go to the schema and table in Hive Metastore, we will see the same error, and we can go into the Databricks file system and see that this DBFS location no longer exists. So this is simply an orphan table reference that didn't get deleted when its data was. If we delete this table reference and rerun, we will have one less error. Once you've cleaned up any errors and the run bar is green, you will know you have a complete assessment of this workspace with no unknowns. The Hive Metastore inventory catalogs all the different parts of the current Hive Metastore. The tables are of course the most important feature, as the data tables are what actually will be moved from Metastore to Unity Catalog, so this number is the first indicator of the level of effort. If the number is 100,000, then the migration will take quite a while, and if it's a couple hundred, as you see here, it will take much less time. It largely depends on the expertise of the person migrating the data, but an experienced Databricks engineer should be able to migrate a few thousand tables a week using standard scripting techniques. Another big factor immediately evident in this example is when the workspace items like notebooks and files greatly exceed the number of tables. When we see this, it generally means there's a lot of ad hoc code in this workspace, and often that means lots of nearly identical notebooks with only one line of code difference sharing tables over and over again. This adds complexity to migration because we can expect a lot of ad hoc table references that need to be handled inside the code for things to work and run in Unity Catalog. That's where one of the most useful features of this assessment comes into play, the active Hive Metastore footprint. In other words, we will highlight which tables, jobs, clusters, files, and libraries have been actively used recently. That doesn't mean everything else other than these 40 tables and these 15 files or notebooks can be written off as old and stale. But it does mean if you want to ensure your regular usage in this workspace is covered, then you can focus on just the active elements first to get up and running on Unity Catalog as soon as possible, and maybe leave the stale tables and notebooks till a time when they are used again, if ever. The rest of the inventory items are all elements that interact with the tables differently in Unity Catalog. Users in Unity Catalog are raised to the account level so you can manage them all in one place rather than individually in each workspace. Grants are encouraged to be handled more as groups and less individually, so you might find you can repurpose 300 or even 3,000 into a handful of groups. Our recommendations create a virtual checklist of what needs to happen in a migration with links to Databricks documentation to help you walk through the process of migrating the actual data if you're planning to do so on your own, or just want to know more about the process. Good examples here, over 92% of tables reference a location in the Databricks file system. The data needs to actually be moved to the new system. A CTAS or deep clone can be performed to move the tables stored there into Unity Catalog. Lastly, if you really want to dive into the individual data, you can export the results of the report into Unity Catalog to be viewed and queried on there. If you're going to be performing your own migration, then these results can serve as the foundation of the scripts you will write to perform the actual actions that make up the migration itself. Inside Databricks, we can open up our full list of tables, databases, grants, and all the moving parts of the Hive metastore and see all the current information on that and access that through scripts and Databricks. With that, you can begin to build configurations for the scripts that will move and rename these elements based on the table elements. Like maybe you want to consolidate all grants with a specific permission into one grouping. Whatever your programmatic solution, this assessment provides a good foundation to approach. I hope this video gave you a better understanding of what would be involved to migrate your workspace to Unity Catalog. If you have further questions, please don't hesitate to contact our support team at support@bpcs.com.